All right, so today we are doing day 2 of chapter 4. It is section 4.2 from your textbooks. It's all about polynomials. There is a space for this definition in your notes, so go ahead and write it down. A polynomial is an expression that is either a number, a variable, or the product of a number and one or more variables. There's no addition, no subtraction, no variables in the denominator. So I believe it was chapter 2 we talked about terms and how terms are separated by plus and minus signs. Mm-hmm. So a monomial only has one term. So there's no plus or minus signs, there's just that term. And a term can have multiplication in it, it just can't have addition and subtraction. So it can have a coefficient, it can be a constant, meaning no variables, it can have multiple variables in it, as long as there's no adding or subtracting. All right, so here are some examples of monomials. 3 would be a monomial, x would be a monomial, x squared, y to the 4th. Negative 2/3. Here are some that would not be monomials. Anytime you see a plus or minus sign, that means you have more than one term. And then you also cannot have any variables in your denominator. That makes it not a monomial. So the definition for a polynomial is a sum or difference of monomials. So you're taking multiple terms and you're adding or subtracting them. And then those have special names. So one term we call monomial, 2, like a bicycle has 2 wheels, right? Binomial. 3 terms is a trinomial. And then any more than 3, you just call it a polynomial. Just generic polynomial. And then a term without a variable we call a constant. So let's say you have a polynomial that has a plus 4 at the end. The 4 is the constant. There's no variable. The value of that term never changes. It's constant. The coefficient is the numerical factor of a term. That's kind of the formal definition. The easy way to think of it is it's the number that's in front of the variable. Co means works together, right? So it's the number that works with the variable, coefficient. All right, and then the degree of a term is the sum of the exponents of that term. Or if we are looking at the degree of a polynomial, that's the degree, the largest degree, meaning the largest sum in the term. The term with the largest sum. Questions on that? All right, here's example 1. Part A, so we have 4x squared y to the 3rd z, and it says find the degree of this monomial. So let's give everyone a second to write it down. Yes, ma'am? The degree is 6. So you add the exponents of the variables. So the 2, the 3, and then z. What's the exponent with the z?
1.
1. Good. So 2 plus 3 plus 1 is 6. All right, what do you guys think on this one? Yes.
6 or 9?
6 or 9? You tell me.
I mean 9.
9, yes. So 3 plus 5 plus the 1 again is 9. Yes, ma'am.
1. Wait, no, 0.
0, yes. Remember, it's the exponents with the variables. There is no variable here, so it's kind of like having an x to the 0 power. So the degree is 0. All right, and part D. Yes? Yeah, why is it not 13? Yeah, don't throw that extra 2 in there. That's the exponent with our coefficient. We don't want that. You just want the exponents of the variables added together. What are your questions? All right, and then I was hinting at this earlier. If you're looking for the degree of the polynomial, it's the greatest degree of its terms. So you find the term with the largest degree, that's the degree of the whole thing. All right, so we want the degree of this polynomial. So find the degree of each term. Whichever one's the largest, that's the degree of the polynomial. What are you thinking on that one?
The last one.
Okay, so yeah, the degree of each term, the first term, the degree is 6, then 5, then 8. So the degree of this polynomial would be 8. It's just the one that's the biggest. Yes, ma'am.
On the line, like, when we write 8, or when we write
You'd write 8. Pick the biggest one. Yep. The ones in purple, that's just showing you the degree of each term. All right, here's part B. Yes, sir, in this row that I'm sitting in.
Oh, the last one?
The last one. So the degree of each term, we have a 7, we have an 8, and we have a 12. So he said the biggest one is the last one. So our answer would be the degree is 12. Questions on the degree of a polynomial? All right, here's example 3. All right, so you just have to fill in the blank. How many terms? Terms are separated by plus and minus signs. So we have 3 terms. 1, 2, 3. Good. What's the constant? Yes, ma'am. There is not a constant. Remember, the constant is the term that doesn't have any variables. All right. Yes, sir. The coefficient of the second term?
7 or negative 7?
Negative 7. Good. You got to keep the negative with the term. And then what type of polynomial is it if there are 3 terms? Yes, ma'am. trinomial. Like a tricycle has 3 wheels, a trinomial has 3 terms. What are your questions? All right, what's the degree of each term? 7, 6, and 14. Good. What's the degree of the polynomial then? 14. It's just the largest degree of the terms. Questions? All right, here is number 4. Arrange so that the powers of x are in ascending order. Ascending order means getting bigger. So we want the x's to be getting bigger. So you put the term with the smallest x exponent first. So see how this one has an exponent of 3, this one has an exponent of 5, this one has an exponent of 4. We're going to rearrange those so they get bigger. And remember, the sign in front of that term stays with the term. So we start with this guy. Then we put the x to the 4th power, the whole term. It was plus, still plus. Then we want x to the 5th in the back. It was minus, it's still minus. This honestly feels weird to me. Typically when you have exponents, we go in descending order from biggest to smallest. But the key is reading the directions. If the directions say ascending order, that means getting bigger. All right, this is the one I'm more used to. If I wanted to write this in descending order, which one would have to go first? Yes?
3x, 4, y, 7, z, 3.
Descending order. So we want the biggest exponent in the front. The biggest exponent. Oh! Whoops. I didn't see it was a y. Sorry, I thought we were still talking about x. So you want the biggest y. So which one did you want to start with?
3x, 4, y, 7, z, 3.
Yeah, this guy. So the y's. Sorry, I was looking at the wrong variable. Y to the 7th, y to the 1st, y to the 4th. So you want 3x to the 4th, y to the 7th, z to the 3rd in the front. Then you want the 3x to the 3rd, y to the 4th in the middle. And then this guy. Sorry, I was looking at the wrong ones. My bad. And this, like I said, is more typical. Typically, you want to start with the biggest exponents and then go down. Just make sure you're looking at the right variable. Questions? All right. Now, we're going to practice adding these. So the key is to add the terms that are like terms. So this is like chapter 2 stuff. A squareds go with A squareds. ABs go with ABs. B's go with B's. A's go with A's. Regular old numbers go with the other regular old numbers. We call those the constants. And we typically write these in descending order of exponents. Okay, so I'm going to write the A squareds first. So what's 2a squared plus 4a squared? Yes?
6a squared.
6a squared. Good. Then we want the ABs. Then we want the B's. Then we want the regular old constants. So we'll have 6a squared. Here we have 1ab minus 3ab. That's minus 2ab. Nothing combines with this b. Leave it alone. Nothing combines with the 9. Leave it alone. What are your questions? Yes, ma'am. Oh, okay. Here's the next one. So it's a little different when you're subtracting because you're not just subtracting the first term in the parentheses, you're subtracting all of the terms in the parentheses. So you have to distribute the negative sign. It's kind of like multiplying through by a -1. So when I rewrite this, I'm actually subtracting the 4ab and I'm subtracting the 6b squared. Yes, ma'am.
Which one would you put first?
So when you're doing this, and this is where it kind of gets tricky, when you have two variables, like here we have a squareds and b squareds, and then we have some that have a's and b's together, you usually go in alphabetical order with the combination in the middle. So since a comes first in the alphabet, we want the a squareds up front, and we want the b squareds in the back with the combination of a's and b's in the middle. It's kind of weird. You'll get used to it as we do it more often. If you put the a squareds then the b squareds, I wouldn't count it wrong since I know it's kind of tricky when you have two variables. As we get into farther chapters, you'll see why we write them this way. But yeah, just focus on descending order of exponents and alphabetical order for variables. All right, here's part C. Once again, we have some binomials. One of them is being subtracted. So we want to subtract each of these terms. So when I rewrite this, I'll have 7a minus 10b and then minus 3a. And then what's a minus negative? Plus. So in the back, you'll have plus 4b. All right, combine like terms. So the a's are going to go together. What's 7a minus 3a? 4a, good. And the b's are going to go together. Keep the negative with the 10. What's negative 10b plus 4? Very good. Questions? All right, here's part D. Yeah, so here we're adding them. So the parentheses aren't really doing much for you. If you want to rewrite it without the parentheses, that's fine. If you want to go right into combining like terms, honestly, I don't see a problem with that. So the y's are going to go together, the x's are going to go together, and the a's are going to go together. Now, in this particular example, they wrote it in the order that they appeared in the problem. Like I said, that's not necessarily the way I would do it. I usually stick to alphabetical order and descending order of the exponents. But if you had this as your answer and I had on my answer key 7a plus x plus 6y, I'd be fine with it as long as the directions didn't specify. Remember, addition is commutative, so as long as you keep your signs straight, you should be good. Keep your signs straight and follow the directions. All right, so this says find the missing side if the perimeter is 12x squared minus 7x plus 9. What is perimeter? How do we find perimeter? You add all the sides. So in this case, what's the opposite of adding all the sides? Subtracting, right? So if you start with the perimeter and you subtract the two sides that you already know, that should give you the side that you're looking for. Everyone see the strategy here? So we're doing the opposite of addition. We're undoing the addition to see what we would need to add to make this the perimeter. Now, I will need to not just subtract the first term, but all of the terms. So I'm going to first distribute that negative after combining the like terms. So they shortened it up here for us, which is great. X squareds go together to give us 11x squared. 2 minus 8x gives me negative 6x or minus 6x. And negative 1 plus 5 gives me plus 4. Now you can distribute the negative. If you distributed the negative first, you should end up in the same spot, but this is actually the more correct way to do it. It's just less writing, less distributing. Any questions how I got here? All right, now just combine the like terms. So the x squareds are going to go together. 12x squared minus 11x squared is just x squared. Negative 7x plus 6x is negative 1x. And then positive 9 minus 4 is plus 5. What are your questions? All right, let's summarize these. So what did we talk about today? Yes, sir. Monomials, good. And you're right, not just monomials, but polynomials in general. Great, and then you write the other two. I haven't graded notes in a while, which means you probably have a notebook check coming up here, maybe at the end of this chapter. So make sure that you're doing what you're supposed to do with your notes as far as summarizing them and marking them the next day, because that will sneak up on you. Not something I do every chapter, but it's definitely coming up.